Hello everybody. Thanks for coming to this weekly office hour. And the professor said that he will join us, so let's just waiting for a few minutes.
Hello, Chuck, can you hear me?
Yeah, I can hear you.
Okay, great. So I guess we are live already. Okay.
Yeah.
So welcome students to our Hangout for the Embedded Software Optimizations class. I hope you're all doing well. And we are sorry we had to last minute reschedule the office hours from yesterday to today. It is proving to be a little tricky to find a good time, and there are a lot of other constraints. And we'll try to talk to the TA and we'll settle down on a fixed time so that we don't have to keep shuffling things around. Most likely, we'll do it Friday a little bit earlier, because 10 p.m. Many of us have issues joining. We'll try to keep it early so that those who are in Far East, China, India, Korea can probably join around their midnight. If we do it 11 a.m. Friday, that should prove to be a good time for everybody, hopefully, because I think 10 p.m. works out to be a little bit tricky. So anyhow, we'll announce that and we'll keep it fixed beginning next week. So as usual, we'll start with a couple of announcements in terms of the homeworks, projects, and so on. So homework 1, I hope it went well for all of you. And we are starting to grade it, and we'll return it back next week. The TAs have a solution and the rubric for grading, and so it shouldn't take too long. Next week sometime you should be able to get it back. The second announcement is about the project part 1, and hopefully all the teams have started. There were some glitches I heard about deep thought accounts. I think Chao will comment on those. There were just a couple of students who had some issues about their deep thought accounts. We are in touch with David Mercer, who is resolving those. Hopefully they're already resolved. And I hope all of you have started working on the project. Even without waiting for these deep thought issues, you should come up with a strategy, come up with a solution and code it up, and then test it out inside the Vagrant, the VM. That's what we recommend, so that we don't lose time. Due to summer semester, we are really short on time, usually at almost by a week or so. So please do not wait. And that's the suggestion I have. This is about, as you know, VLIW scheduling, familiar topic, and we've given you a very small piece of code, and we have asked you to implement a heuristic, which shouldn't be too difficult. So understand what is going on, and you are given some utilities which will allow you to look at the instructions, find the dependencies, construct the dependence graph, and all these concepts should be very clear. We have covered those in the book and the lectures, so it shouldn't be too difficult to come up with a solution. Then we also given you the algorithm. So we should be in good shape there. The other announcement, the last announcement, is about homework 2, which was just assigned yesterday, and that's another interesting piece of thing to be done, which is about compaction of instructions. You have read in the book and in the lectures many different types of compactions or encoding schemes. So we're asking you to implement a couple and compare the results. Again, we are giving you some benchmarks. We're giving you some utilities which will allow you to dissect an instruction and look at different parts of it, and then you choose an encoding scheme and find out or implement the compaction and then compare the results. So that is this homework about. It also needs the Vagrant, and if you follow those instructions, the Vagrant should be in place regardless of deep thought, and you can work on your own PCs or laptops. The homework is to be done individually and like a project, which is a team effort. So just a clarification about that. And that's also due in a couple of weeks. So you should start gearing up for that. Some of these things have long descriptions. Don't get perturbed by that. It's just we are trying to explain and give all the details because a lot of learning in this class does happen through these projects and actual hands-on coding the project, and this particular homework is about programming. So that is why there are a lot of details which will help you to understand and also implement it properly. So that's why the length of the description. But the amount of work is not big at all. It's also not too small. So I think it's a good idea to get started on time and don't keep it till the last minute. Other than that, the last one announcement, then I will hand over to Chao for any other additional announcement about Vagrant or any other details he wants to add about the VM and so on. So now you must have started pacing the compiler part of the class, because the part 1 is as per the pacing schedule is done. So we have some introductory lecture there, which is about how the compiler's overall working is, and there is an associated reading with that. And then we have control flow graph, which is given the intermediate form. That is where we really start for this class, how to construct a control flow graph. From there, do some register allocation. So those are the basic topics for the second part, which will prepare the foundation of how the register allocation in particular is done. We have covered instruction scheduling in our first part. The second part mainly deals with memory and register allocation, which are very critical for performance on embedded systems. And this first few topics or lectures set up the foundation for that. And then we go and read the state-of-the-art papers, about 4 of them. And that's basically the end of the class after that. So please carefully understand, this topic might be new to some of you because those who coming from EC background may not have any software or compiler sort of experience or background. But if you pace it carefully and read it, it is pretty logical and straightforward. And in case you run into any issues or any problems about any concepts especially, then do let us know. And the live range, which is the key concept, allows us to determine how long we should keep a value in the register. It's an interval from the setup of the value, which is we call as definition, to the last use. And I think it will, if you pace it properly, read the material, go back, understand, and we'll be, of course, doing some homeworks as well there. Simple exercises to test the concepts or to re-emphasize those, which will help you prepare for finals as well. So you should be in good shape there. That's what our recommendation is. There was small discrepancy in terms of the actual lecture numbers. I posted a announcement yesterday, and I have corrected it. Please follow the schedule. You are supposed to read the underlying material along with the lessons, pace it together so that you understand the topic, both in terms of textbook or the papers and videos. All right, so I think that's all I have for as far as the announcements. So Chao, you have any thing to clarify or add about the Vagrant or the Deep Thought accounts, or any issues or anything that you're seeing in terms of project? We can't hear you, Chao. I think you are muted.
Hello?
Yeah, you're good now.
So, I mean, regarding this to the account, I think I have sent the error messages to the David, but I haven't heard from him yet. I think that the issue comes from need some like pseudo privileges to rebuild the VirtualBox. And as confirmed by previous TA, actually it definitely can be used in the local PC or laptop. So for those who have some issues with accessing to the deep thought, you can definitely use your laptop for the experiment. It should be fine. And regarding this to the project teaming, and actually, most of students has already formed a team, but with like I think I remember it's 4 students. So formally, I just manually formed them together and made an announcement. So I hope this assignment is okay to them. But please check if there is any issues about the team information. Please just let me know. I can fix it. So I think that is all my information from my perspective.
Thank you, Chao. Yeah, I think the teaming should have been done earlier because we have a very short fuse. As I have been mentioning, in terms of the short summer semester, we cannot give any extensions. So if it's students' responsibility to form the teams, and if they cannot, immediately let Chao know, and whatever team we have formed now, that will be the one which they will have to go with, because we cannot change the teams nor move students around at this point. There's already a delay here, about a week. And the second thing I would like to also emphasize in terms of what Chao said is, do not wait for deep thought to issues to get resolved. Things have been slow in terms of response from the system administrators. We are trying our best to get it resolved, but please go ahead and download the Vagrant on your own environment and work inside those on your PCs or laptops. And you can use GitHub for the versioning side of the project between the two team members. So I think that is a preferred solution path which we're recommending, because the time is really precious, and we cannot lose any more time, either on terms of teaming or in terms of the deep thought issues. So please go ahead with that, because we will be giving the part 2, which is also toward the end of the month, after the due date for the part 1. And so please, we need to get things done on time here. All right. So Chao, are there any questions we need to tackle here at this point?
Yeah, there is some questions posted at Piazza. I think the first question is actually from last time. He's asking about what is the benefit of data speculation if without knowing whether there is a data dependency.
Okay, so data speculation is typically is used for common cases. The idea here is this, that in terms of being able to remove a constraint, that is the biggest benefit. So if you speculate, you don't know when there is a dependence. So there is a chance there might be a dependence. There is a chance there may not be a dependence. So this applies mainly to the memory dependencies, because, for example, 2 references, load and stores, they could go to different addresses, in which case there is no dependence there, or they could go to the same address, in which case there is a dependence. And in terms of instruction scheduling, if we speculate that there is no dependence, which is kind of an optimistic assumption, we are able to move certain instructions. For example, loads can be moved over stores upwards, and that allows us to get the data early in, because remember that the loads have latency, and the earlier they can be hoisted in terms of instruction schedule, the better it is, because they are likely to get their data, and the dependent instructions are unlikely to stall. So speculation allows us to do this type of code motion to move the loads earlier, so that we can meet the latency requirement for the use of the loaded value result. Now, of course, speculation is a speculation. In other words, things may be true, things may not be true. And if they're true, which is our optimistic assumption, then we don't need to do anything. But if they're not true, then we need to take care of the value that is loaded, because it may be a wrong value. So for example, if load and store collide, they have the same address, then the value is stale, which is loaded by the load instruction in the register. So to correct the misspeculated value, we need to re-execute certain code. Typically, we have to maybe re-execute a load so that we get the right value and then continue. So there is a penalty associated with the misspeculation, which is to redo the operation, and of course that also affects instruction schedule, latency, etc. But common case that we are assuming is that we will not have this particular situation. The speculation will be right, and so that way we'll have the benefit of loading the value early. So that is the reason we have data speculation, and that's how it works. Control speculation, on the other hand, is about the outcome of the branch, or sometimes the target of the branch, where it will go. And they also work in a similar way. And we start executing the instructions which are on the speculated path. And of course, if the speculation is wrong, then we have to undo their results. We typically don't commit their results. They're in register, so we simply throw them away. And the memory is not affected, and we start executing the right instructions. So, but that's the way the control speculation is a different one. It starts executing the instructions on the particular side of the branch and where the branch goes for the next PC address. Both are being speculated there. And if there are misspeculation, then obviously all of them had to, the things had to be discarded. Typically, they're only in registers, not written to the memory. So the state is not really affected. And you simply do nothing but start executing a new set of instructions, and then start committing them. Again, there's a penalty here. So that's the control speculation. Thanks for the good question. Chao, what's the next one?
Okay, the second one is from Brian, and he's asking what is a bypass network?
Bypass network. Is there more to the question? Because this term is used in multiple situations. Is there more to it?
It just what is bypass network?
Okay, I'll try to answer making some assumptions here, so one of the uses, and this will build on top of what we just talked about, is a mechanism called load forwarding, or store to load forwarding. And the idea there is, suppose you have a store which is writing data to memory, and then following that you have a load which is reading from the memory. So you can see that this is a dependence now. And you will have a lot of latency here because the load has to complete, then the store can start, and so on. So to avoid this particular, and this occurs quite a bit in real code sequences or instruction sequences, to avoid this huge dependence and latency delay, typically there is a small network which goes from the right buffer of the memory controller to the read buffer, and this bypasses the other mechanisms which are there in the memory controller and just directly sends the value. This is called as load forwarding or store forwarding to the load. So the value, instead of fetching it from for sending it to the memory, so rather say fetching it from the memory, the value is simply fetched from the existing buffer, which is the store buffer. And that way you save some latency, and that's why it is called as bypassing the memory controller's action, which is getting the value from the memory, and that saves you a latency. So this is one use of this type of bypass network, which allows you to do this. I'm not sure if this was the context of the question. If not, please add some more details and we can take it up. Thank you.
Okay. The third question actually is from Ben. And he asked several questions about the project. I think is maybe interesting. The first question is, in the project 1, do they supposed to implement the register renaming?
I believe, let's open the register, the description. Let me see if I can open it quickly. Do you have it handy, Chao?
Yes.
Okay, what does the project description say? Does it say it?
It has no such information in the description.
About the renaming?
No renaming.
Okay. So then please assume that we are not going to do it because that's an additional step, and it does need a little bit of work. And again, the project duration is rather short, so we probably not asking you to do it this time. Renaming is making sure that the registers are changed so that any dependencies are removed, and that way we have a much better instruction schedule. It is quite possible to do it by reassigning registers, but that basically means you'll have to do some analysis, change all the register names, and it will add more complexity. So please assume it's not there.
Okay, the second question from Ben is about the function units. Because in the project it described there is 4 function units, and he wants to know especially what these 4 function units refers to. It refers to 4 ALUs or just for different mathematical operations like adder or multiplier.
So that is as per the VEX bundling restrictions. In the VEX, I think you cannot have 2 loads at the same time. So please check those restrictions on a 4 wide instructions. What could be the operations that could be done together, and those are the ones to be followed when you generate the instruction schedule. So that's have we posted the VEX manual there? We have, I think, right?
Yeah, we have a Fox manual. Actually, in Fox, I think it refers to ALUs. So you can, like, if there is 4 additional operations, they can be scheduled at the same time, but on 2 different function units. It's to my point. Yes.
Right. Okay. So first 2 are ALU, and then the other ones, the 3rd and 4th.
The third one is about because in the coder table there is a scheduling folder, and one is for speculation folder. I think the speculation folder is for the project 2. So right now they just need to focus on the first project is scheduling.
Right. Okay.
And I think lots of questions is asking about the assembly file provided with the project. Actually, all of these assembly files are used for testing one kinds of stuff. So it has no special meanings, and it just is for testing. But you can also construct your own like program with assembly language for test purpose.
Right. So yes, the thing that we are asking you to do is, of course, this is a linear sequence of instructions. We're not assuming any control flow or anything to keep things simple. And so what you could do is you could write some simple program which has no control flow, or take a very small loop and even turn on unrolling when you compile it using the VEX compiler and so on. And it will create a long sequence of instructions which has no control flow. So you can use all of these for testing. We recommend that you do create your own test cases and test it thoroughly so that you understand how the scheduler is trying to schedule instructions, not just for this one, but for any kind of code. Again, the goal here is to write a scheduler which will work for any linear sequences of instructions. And of course, test it on this one and any other one which meets, there's no control flow requirement there. All right.
Yeah. Okay. Final two questions is from Awanish. And the first question is about the list of scheduling algorithm. I think this question has already been answered by Daryl. I'm not sure whether his answer is satisfied or not. I think the second question from Awanish is about the compactor encoding. And because in the lecture, when you explain the compactor encoding, you encoded the loops in the process in the instruction stream, and in the book, when it explained, it skipped the loops. But finally, you both get the same code result. So here's a confusion whether which one is correct, and why these two different methods would result in the same result.
So this is a Piazza question, right? Which he has posted some examples which are compacted using the lecture scheme versus book scheme. Is that right?
Yeah.
And then why are they different? So I'll have to take a look there. So just can you flag it for me? I'll go to Piazza and look at it. It's possible that there is a slight difference in terms of the conventions used. And do you have a take on this, Chao, yet on this question, since you have looked at it?
I haven't taken it into details. I checked, so there is some differences, but I need to check the book again to check whether there is some difference about the convenience, different words.
Which scheme is this? The compact encoding scheme?
Encoding scheme, actually. It's.
There are multiple of those, though. Which one is he mentioning?
Especially, I think it's about. Let me check. It's about instruction encoding. Right.
Okay, let's just, Okay,
I'll forward this to you, and I'll have a double check.
Okay. Okay, let's take that offline. Okay.
Okay. Okay, Ben, I think that is all of the questions posted in the Piazza.
All right. That's about it. So we'll take a look at this offline in terms of the encoding schemes. So just wanted to talk a little bit about encoding scheme. The main thing that I want to emphasize is this, that the compaction of instructions and compression, there have been lots of interesting efforts on this, and they have been geared towards different kinds of things. So very low bandwidth in terms of transmission and mobile code. Okay, especially in some networks which have extremely low bandwidth, which are very local, but which need to have mobility in terms of code. That is one of the reasons why we want to reduce the code size, compress it, and we will. So there are two types of schemes used here. One is just pure compression, like Z compression algorithms and all these things which are there. But these compression algorithms, they're expensive on embedded processors because then you have to decompress that, and the decompression also costs time and energy, especially. So that is one of the reasons why compression is not such an interesting idea, especially for embedded processors. So the second direction is encoding and decoding, which is much faster, in which what we are trying to do here is take bits and pieces of instruction and remove some unnecessary information and put it in a format and send it. And then before we use it, we again put it back together. And this has much lower complexity in terms of processing. It works well for most of the time. Of course, the yield of compression, the size of the data that is sent or instructions that are sent are also typically lesser than compression. So those of you who are interested in this particular topic, I encourage them to read outside of, there are some references given in the book, but even more than that, instruction compression. So instructions are a great candidate for compression. The reason is, or compaction, through encoding as well as compression. The reason being that they're all read-only type of things. So they have format also. They have opcodes and different fields and so on. And that format can be used in terms of trying to get rid of certain fields, rearrange them, so on. And they are read-only. So there is no change like data. Data has a lot of entropy. So one item of data and second item of data can be totally different. And that's where neither compression nor encoding really works very well. Okay, so instructions and mobile code, both compression and compaction, they work, or encoding rather, they work very well. And encoding means, as I said, removing certain fields, rearranging those the way we are looking at it in the class. Compression means, of course, using some algorithms such as Z compression and so on, which will try to do something even more. So I encourage you to read instruction compaction from outside, and they're mainly for bandwidths of transmission purposes. Data compression is a totally different topic, and there is some work on that, but that's not solved very well because of the values being very different. There are embedded applications in which most of the values are not that many, but they can be put in correspondence with, for example, simple integers and enumerated and compacted. And that's the reason sometimes it works for certain embedded. So for example, certain embedded controllers have only 5 different kinds of inputs. So you can certainly encode them in terms of log of 5, which is, let's say, 3. And using just 3 values, you can encode. There's not much saving here, of course, but you can see that as the number becomes large, the logarithm becomes a good idea to save some some things there. So there is a way to do it, especially if it's enumerable in terms of the input. So yeah, that's an interesting topic, and compaction in general is a great idea for and as IoT and all these devices are going to show up, this need for sending data or very limited bandwidth is going to increase, and that's where there will be a lot of benefit of these techniques. Okay, any other question, Chao, or are we good for today?
That's all questions.
Okay. Those who are live on the Hangouts, do you guys have any questions? Thanks for coming over. I think this time will work better, but we'll of course do it on Fridays, maybe a little earlier, and hopefully that will also take care of those who are in other parts of Far East Asia and in terms of their local times. We are of course recording all this, and those who cannot join live, unfortunately, because of whatever constraints you have, we understand sometimes there are lots of constraints. Please do take a look at the recordings, and Chao will be happy to. So you could also post a question like we did today ahead of time if you cannot join, and you can of course hear the live answer, and hopefully that will take care of what is going on in terms of so that your questions are not held back. Okay. There is no question, then maybe I think we're getting towards the end of our Hangout. We'll wait for a few minutes, and then maybe we'll call it a day for today. All right, I think looks like we should be good for today, and thank you for coming over. Thank you for your questions. For the next week, we will announce exact time. I'll talk to Chao, and I'm also on travel, so is on Chao. But we'll fix a time, and we'll announce it ahead of time, and we'll then stay with it. Thanks for coming over, and see you next week.
See you.